I know we probably all watched Mrs. Frenken's videos. I hope you have, because every single problem from the final reviews worked out for you. I wanted to talk a little bit more about number 47 and number 48. This was a lesson that happened online this year, and I called the 17.2 section extra credit. Some of you never did it, and you're a little confused, and you watched Mr. Frenken's video, and she went through it as if you had seen it before. But I need to go through it in more detail for those of you who didn't really look at it before. For some of you, it will make the final exam a little bit easier to have one more tool in your toolkit. So these are going to use not just basic sine, cosine, and tangent, because these are not right angles. Instead of using the basic sine, cosine, tangent, SOHCAHTOA stuff, we're going to use what we call law of sines. And law of sines starts with two fractions, and it has the sine of an angle over the side that's opposite to that angle. It has the sine of an angle over the side that's opposite to that angle. In order to be able to use law of sines, I need to look at the picture and see that I have a side, and I have three sides here, but I need to be able to look at and see that I have this angle, and I have the side that's opposite from this angle. Oh, I really lightened up my highlighter. Okay. That means I'm going to start with a fraction that says the sine of the only angle I know over the side that's opposite from that equal to, and since I want to find h, I'm going to do sine of h over the side that's opposite from h, which should be lowercase h. The one that doesn't touch it is this one, 15, and I don't think I need to put the miles in the problem. And whenever I see a fraction equal to a fraction and there's a letter mixed in there somewhere, my first thought is, let's get rid of the fraction. And the way I make it stop being a fraction is by cross multiplying. That means the 15 times the sine 123 equals the 43 times the sine of h. Okay, I'm writing a little crooked here. Okay, maybe that looks a little better. Now, I'm not working anything out. I'm not putting anything in my calculator to the end because I don't want to be using rounded off answers. I need the h by itself, and it's not easy to just divide out the sine part. So I have to get rid of the 43 part of this first. And then I have sine h equals all this stuff, which again, I'm not ready to put it in my calculator yet. Because I'm still going to work on getting the h totally by itself before I bother to put anything into my calculator. The question is, how do you get the h out of its sign? And in order to get the h out of its sign, I have to do h equals the inverse sign, which is usually a little shift or second button on your calculator, and then push the sign button, of all of this stuff I have over here. This 15 times sine 123 divided by 43. If you don't have a fraction button on your calculator that'll let you do a big fraction looking thing like that, that's okay. Just do divide by 43. But if you have a calculator like mine, it's going to mess you up if you don't put some parentheses around that first. So all of that is going to go in my calculator to find the h. Yeah, I paused and put it in my calculator. I got 17.011, And it says round to the nearest degree, which means round it off to a whole number. So I can say the measure of angle H equals 17.0, so just 17. And of course, don't forget to put those degrees on. Let's go back and look at our picture for a minute and see if that makes sense. I should have the biggest side across from the biggest angle, the smallest side across from the smallest angle. This looks like it's kind of a in between. Is it the smallest? It is the smallest side, I say. It is definitely the smallest side, and this definitely looks like the smallest angle. And it looks like 17 is a reasonable answer for that. Number 48 was also from the 17.2 section. The formula for this section says, well, you know, we originally learned if you have a right angle and a triangle, the area equals 1/2 times the base times the height. But even though it's possible to do it that way, that would take a lot longer than what I'm going to show you. We would have to figure out that those were, we're not even going to worry about it. We did that last year. We're going to say, forget that formula. Don't even need the height. We're going to say the area equals 1/2 times the side times the side times the sine of the angle between. Which means that the only angle I know is 36. And I have 1/2. And I need to know that I have the two sides that meet at that angle. If somebody told you this one over here was 9, it wouldn't matter. The ones we need are the two sides that meet at the known angle. So in this case, I'm talking 12 and 12. And really, they're not usually the same number, but this one happens to be. And then all I have to do is put that in my calculator. Okay, 42.3205. We need it rounded to the nearest tenth. And the nearest tenth means I'm keeping one place past the decimal. And I look at that 3, and I say the number after 3 is smaller than 5. So 3 just gets to stay as a 3. And since this was inches, I went with inches. The problem above it, the sides were miles, so I had this momentary thought I should put miles on it. But when they were asking about the angle, I didn't put miles, I put degrees. This one's 42.3. That's all I'm going to work out from here because I feel like Mrs. Frenken's videos did a good job of explaining everything else. But you can always call me or email me if there's another one you really need some help with.